On the morning of March 23, 2025, residents of Phoenix, Arizona stepped outside to witness something that should not have been possible. Dancing across their desert sky, painting the horizon in sheets of emerald and violet light, was the Aurora Borealis, appearing more than 1,200 kilometers south of where the laws of physics said it could exist. The northern lights had come to the Sonoran Desert, as if the Earth itself had forgotten the rules that govern where such magic is allowed to manifest. This was not an isolated event. In the 18 months since our cosmic visitor began its impossible journey through our solar system, our planet has been experiencing what can only be described as a cascade of anomalies, a symphony of strangeness that crescendos and fades according to rhythms that seem to echo the movements of something beyond our atmosphere. The Earth, it appears, has been learning to dance to music played by celestial visitors. The statistics are as beautiful as they are unsettling. Since the arrival of our wandering mountain from the space between stars, the frequency of what geophysicists carefully term unusual events has increased by 347% above historical baselines. This is not the kind of statistical variation that emerges from random fluctuation or improved detection methods. This is the signature of systematic change, the mathematical fingerprint of a world responding to influences it has never before encountered. The Northern Lights, those ghostly curtains that have inspired wonder and fear in equal measure throughout human history, began appearing in places where they had never been recorded. Denver witnessed aurora displays that painted the Rocky Mountains in colors that have no names in any earthly language. As far south as Albuquerque, New Mexico, photographers captured time-lapse images of a light phenomena that defied every model of how charged particles from the solar wind interact with our planet's magnetic field. But the aurora were merely the most visible manifestation of changes that reach deep into the fundamental systems that govern our world. The North Magnetic Pole, that invisible point toward which every compass needle has turned for millennia, began accelerating its drift across the Arctic Ocean. Where it had been moving at a stately 55 kilometers per year, it suddenly surged to 73 kilometers annually, as if something were pulling it toward a new equilibrium that had never before existed in recorded history. The timing was impossible to ignore. Peak acceleration of magnetic pole movement coincided precisely with our cosmic visitor's closest approach to the Sun, that moment in its trajectory when gravitational and electromagnetic forces would reach maximum intensity. Computer models designed to predict magnetic field behavior found themselves confronting data that fell so far outside normal parameters that some researchers wondered if their instruments were malfunctioning. Beneath our feet, the solid Earth itself began whispering of change. 23 earthquakes of magnitude 4.0 or greater struck regions that geological surveys had classified as tectonically stable, areas where the movement of continental plates creates so little stress that major seismic events occur perhaps once per century. Yet here they were, clustering in time and space around the period when our visitor travelled through the inner solar system, as if the planet's crust were responding to forces that geology textbooks insisted could not exist. The most dramatic of these impossible tremors struck Central Australia, a region so geologically quiet that it has remained essentially unchanged for more than 50 million years. The 5.2 magnitude earthquake that shook the outback in July sent ripples through this global seismological community, not because of its intensity, but because of its location. In a land where the bedrock has slept undisturbed since the age of dinosaurs, something had awakened the ancient stones. High above our heads, the atmosphere itself began displaying signs of disturbance that challenged fundamental understanding of how gases behave in the near vacuum of space. Noctilucent clouds, those ethereal formations that typically appear only in polar regions during summer months, began manifesting at latitudes where they had never been observed. These ghostly wisps, formed by ice crystals at the very edge of space, appeared in skies above temperate zones as if the boundaries between atmospheric layers were being rewritten by invisible hands. Indigenous observers, whose ancestors had watched the skies for thousands of years, began reporting phenomena that their traditional knowledge could not easily categorize. First, nation sky watchers in northern Canada described what they called sky sickness, a restlessness in the aurora that seemed to respond to the presence of the bright star that moved against the background of fixed constellations. Inuit elders spoke of earth restlessness, a subtle vibration in the permafrost that coincided with the appearances of lights where lights should not be. The scientific community found itself in the uncomfortable position of confronting correlations so strong that dismissing them as coincidence required willful blindness to mathematical reality. Computer analyses of the timing between our visitor's position and terrestrial anomalies revealed statistical relationships that exceeded 6 standard deviations from random chance. In the language of science, this represents evidence so compelling that the probability of coincidence drops to less than 1 in a billion. Yet academic institutions, bound by peer review processes and career incentives that favour conservative interpretation, largely refuse to consider the possibility that an object travelling through interplanetary space could influence terrestrial geological and atmospheric systems. The idea challenged too many fundamental assumptions about how Earth systems operate, in isolation from cosmic influences beyond the familiar gravitational pulls of the Moon and Sun. The resistance to acknowledging these correlations stemmed partly from the sheer improbability of the mechanism involved. How could a mountain-sized object, even one travelling at tremendous velocity through the solar system, affect phenomena as diverse as magnetic field variations, seismic activity, and atmospheric chemistry? The energy scales seemed mismatched, the distances too vast, the proposed connections too reminiscent of ancient astrological thinking that modern science had long abandoned. But the data continued to accumulate with stubborn persistence. Magnetometer networks spanning the globe detected coordinated magnetic pulses that corresponded to our visitor's orbital position with uncanny precision. Seismograph arrays recorded microtremors below the threshold of human perception that followed 6-hour cycles matching the object's rotation period. Atmospheric monitoring stations measured pressure variations that traced patterns across the sky as if something were drawing invisible lines between our planet and the wandering mountain that had captured our attention and perhaps our destiny. The indigenous observations carried particular weight because they came from cultures that had maintained unbroken traditions of sky-watching spanning millennia. These were not casual observers, but practitioners of sophisticated astronomical knowledge systems that had tracked celestial cycles, predicted eclipses, and maintained calendars of remarkable accuracy without modern instruments. When such observers reported unprecedented changes in familiar phenomena, their testimony deserved consideration that extended beyond Western scientific frameworks. The coincidence problem became impossible to ignore when probability calculations revealed that the observed clustering of anomalies around our visitor's presence represented odds of approximately 1 in 847,000 against random occurrence. In any other field of investigation, such statistical evidence would be considered overwhelming proof of causal relationship. Only in the context of proposed cosmic influences on terrestrial systems did the scientific establishment demand evidence beyond mathematical possibility. As data continued to accumulate through the summer and autumn of 2025, the pattern of correlations grew stronger rather than weaker. Each new measurement, each additional observation, each refined analysis added weight to the growing body of evidence that our world had been touched by something from beyond our familiar solar neighbourhood. The Earth appeared to be responding to the presence of intelligence that operated on scales, and according to principles that challenged every assumption about the relationship between planetary and cosmic systems. The aurora that painted impossible colours across temperate skies were just the beginning. The magnetic field fluctuations that sent compass needles dancing to new rhythms represented only the most easily detected manifestations of changes that reached deep into the planet's core and high into the edge of space. The earthquakes that awakened sleeping geological formations spoke of forces that could reach across the vacuum of space to touch the very foundations of our world. What do you think could cause our entire planet to respond so dramatically to a single visitor from interstellar space? Share your thoughts as we explore the deeper connections between cosmic and terrestrial events that challenge everything we thought we knew about our world's place in the universe. In the delicate symphony of Earth's interconnected systems, something had introduced a new rhythm, a cosmic melody that our planet was learning to dance to despite having no evolutionary experience with such music. The question was no longer whether our visitor had affected our world, but how deeply those effects might reach, and how long they might continue to reverberate through the complex web of forces that make our planet a haven for life in the vast darkness between stars. The signs were everywhere, written in the language of aurora and earthquake, magnetic field and atmospheric disturbance. Our world was speaking of change, and the voice it used carried accents that seemed to come from places far beyond the familiar boundaries of Earth's gravitational embrace. To understand how a visitor from the space between stars might touch our world in ways that manifest as aurora in desert skies and earthquakes in sleeping continents, we must first acknowledge a truth that modern civilization has largely forgotten. Earth does not exist in isolation. Our planet dances through space in constant conversation with cosmic forces that shape everything from the rhythm of ocean tides to the magnetic field that shields us from solar radiation. Consider the Moon, that ancient companion that has watched over our world for 4.5 billion years. With a mass of 7.35 times 10 to the 22nd kilograms, it exerts gravitational influence so profound that it moves entire oceans twice each day, lifting billions of tons of water in tidal bulges that follow its passage across the sky. But the Moon's influence extends far beyond the seas that rise and fall in response to its pull. The solid Earth itself rises and falls by as much as 50 centimeters during each tidal cycle, flexing like a vast, slow-breathing organism as gravitational forces stretch and compress rock and metal across distances that challenge human comprehension. Even the atmosphere responds to lunar gravity, creating subtle pressure variations that affect weather patterns and atmospheric chemistry in ways that meteorologists are only beginning to understand. This is the power of a single celestial body operating across a distance of 384,000 kilometers. Yet the Moon represents just one voice in a cosmic symphony that includes influences flowing from distances measured in millions and billions of kilometers, forces that speak in the language of gravity and electromagnetism across the vast spaces between worlds. The Sun, our local star, dominates this celestial orchestra with gravitational and electromagnetic forces that dwarf anything else in our solar system. Its 11-year magnetic cycle drives not only the aurora that dance across polar skies, but weather patterns that affect global climate, radio communications that connect human civilization, and charged particle streams that can disable satellites and threaten astronauts venturing beyond Earth's protective magnetic embrace. During periods of high solar activity, magnetic storms triggered by solar flares can induce electrical currents strong enough to disrupt power grids across entire continents. The famous Carrington event of 1859 generated aurora visible as far south as the Caribbean, while telegraph systems sparked and failed across North America and Europe. The Sun, nearly 150 million kilometers away, reached across the vacuum of space to touch human technology with invisible fingers of electromagnetic force. But solar influence operates on timescales far longer than the familiar 11-year sunspot cycle. Astronomers have identified correlations between solar activity and terrestrial climate patterns spanning centuries and millennia, suggesting that our star's variable output affects everything from ice ages to agricultural productivity across geological time. The Maunder minimum of the 17th century, a period of reduced solar activity, coincided with the Little Ice Age that transformed European agriculture and contributed to social upheavals that reshaped civilization. Even more distant objects exert measurable influence on our world. The gravitational dance between Jupiter and Saturn, those giant worlds that orbit the Sun every 12 and 29 years respectively, creates periodic alignments that correlate with increased volcanic activity on Earth. The astronomer Johann Encke documented these relationships in the 19th century, noting that major volcanic eruptions showed statistical clustering around times when the gas giants aligned their gravitational pulls. The mechanism underlying these correlations remained mysterious, until modern planetary science revealed how gravitational forces from distant objects can affect the distribution of mass within Earth's interior. The molten rock and metal that flow in the mantle and outer core respond to external gravitational influences, creating convection patterns that affect everything from magnetic field generation to volcanic activity and earthquake timing. Interplanetary space itself serves as a medium for transmitting influences that operate according to principles more subtle than direct gravitational attraction. Cosmic dust, the microscopic debris of ancient asteroid collisions and comet disintegrations, affects atmospheric chemistry by providing nucleation sites for cloud formation and altering the chemical composition of the upper atmosphere. Even these tiny particles, individually weighing less than a grain of sand, collectively influence global climate when their flux varies due to planetary motions and solar system dynamics. The recent detection of gravitational waves by the LIGO Observatory revealed that space-time itself carries information across cosmic distances, allowing us to sense the collision of black holes occurring billions of light-years away. These ripples in the fabric of space itself affect every atom in their path, stretching and compressing matter by amounts smaller than a proton's diameter, but measurable by instruments sensitive enough to detect such minute distortions. If black holes colliding in distant galaxies can create effects detectable on Earth, how much more might a massive object travelling through our own solar system influence the delicate balance of forces that govern our planet's behaviour? Our cosmic visitor, with its estimated mass of 2.1 billion tonnes, moving at 26.33 kilometres per second, carried kinetic energy equivalent to the world's entire nuclear arsenal travelling at relativistic velocity. Such enormous kinetic energy, concentrated in a single object following a trajectory that brought it within the orbit of Mars, represents a gravitational and electromagnetic disturbance unlike anything our solar system has experienced in recorded history. The gravitational field surrounding such a massive, rapidly moving object would create tidal forces capable of affecting any system, sensitive to minute changes in acceleration or electromagnetic field strength. The mathematics of tidal force reveal how even small objects can exert disproportionate influence when they approach sufficiently close to sensitive systems. Tidal forces increase with the inverse cube of distance, meaning that as our visitor approached its closest point to Earth, its gravitational influence would have grown dramatically more intense than simple distance calculations might suggest. During its closest approach, our wandering mountain created a temporary gravitational gradient across Earth's diameter, with one side of our planet experiencing slightly stronger attraction than the other. This differential force, while tiny by everyday standards, operates on a planetary scale where even microscopic accelerations can trigger cascading effects through interconnected systems that have evolved to operate within extremely narrow parameters. The electromagnetic influence of our visitor presents an even more complex puzzle. Spectroscopic analysis during its active phase revealed surface properties suggesting significant electrical charge, possibly accumulated during its journey through the charged particle environment of interstellar space. A charged object of such enormous mass moving at high velocity through the solar system would generate electromagnetic effects detectable across vast distances. The interaction between our visitor's electromagnetic signature and Earth's magnetosphere could explain many of the anomalous aurora observations that began appearing during its transit. Charged objects create disturbances in magnetic fields that can focus and redirect the streams of solar wind particles responsible for aurora formation, potentially concentrating these particles into beams that penetrate deeper into the atmosphere than normal solar wind interactions allow. The 7.3-hour rotation period of our cosmic visitor created a lighthouse effect, with any electromagnetic emissions sweeping across space like the beam of a cosmic beacon. This periodic variation in electromagnetic field strength could have created resonance effects with Earth's natural electromagnetic oscillations, amplifying small disturbances into larger disruptions of atmospheric and geological systems. Earth's fundamental seismic frequencies, the natural vibration modes that characterize how our planet responds to disturbances, include periods remarkably close to our visitor's rotation cycle. When external forces operating at frequencies that match natural resonance periods affect complex systems, small inputs can create disproportionately large responses through the amplification effect that engineers call resonance coupling. The cascade theory of terrestrial response to cosmic influences suggests that our planet's interconnected systems act as a vast network of feedback loops where small disturbances in one domain can propagate and amplify through others. A magnetic field fluctuation might affect atmospheric chemistry, which influences cloud formation, which alters regional climate patterns, which changes ocean circulation, which affects tidal patterns that influence earthquake timing. Modern Earth system science recognizes that the atmosphere, hydrosphere, biosphere, and geosphere operate as components of a single integrated system where changes in any one domain can trigger responses throughout the others. This interconnectedness, while providing stability under normal conditions, also creates vulnerability to external influences that can propagate through the entire system when they exceed certain thresholds. The solar wind modification effect represents another mechanism by which our visitor might have influenced terrestrial systems. As a large electrically charged object moving through the stream of particles flowing outward from the Sun, it would have created a wake disturbance similar to how a ship creates waves in water, or an aircraft generates turbulence in air. This wake effect could have focused solar wind particles into concentrated streams that struck Earth's magnetosphere with unusual intensity, or from directions that our magnetic field was not optimized to deflect. The resulting enhancement of aurora activity and magnetic field disturbances would then trigger the cascade of atmospheric and geological responses that characterize the period of our visitor's transit. The butterfly effect, mathematically formalized in chaos theory, demonstrates how systems characterized by sensitive dependence on initial conditions can amplify microscopic changes into macroscopic effects. Earth's climate system exhibits exactly this kind of sensitive dependence, where tiny changes in atmospheric temperature, pressure, or chemical composition can trigger shifts that affect weather patterns across the globe. If our cosmic visitor created even minimal disturbances in Earth's electromagnetic environment, atmospheric chemistry, or gravitational field, these changes could have amplified through chaotic feedback mechanisms into the dramatic anomalies observed during its passage. The apparent impossibility of such small causes creating such large effects dissolves when viewed through the lens of complex systems theory and nonlinear dynamics. The historical precedents for cosmic influences on terrestrial systems extend far beyond the familiar examples of lunar tides and solar magnetic storms. The Tunguska event of 1908, when an asteroid or comet fragment exploded in the atmosphere above Siberia, created atmospheric disturbances that persisted for weeks and affected weather patterns across the northern hemisphere. If a single atmospheric explosion could influence global climate systems, how much greater might be the effects of a massive object transiting the entire inner solar system? The question is not whether cosmic forces affect Earth, but whether we possess the wisdom and humility to recognize influences that operate according to principles more subtle than the gravitational and electromagnetic effects we have learned to measure and predict. Our visitor may have spoken to our world in languages that terrestrial science is only beginning to understand, using the vocabulary of resonance, cascade effects, and system-wide responses to create changes that ripple through every domain of Earth's complex, interconnected existence. As we prepare to explore how these cosmic influences might manifest in the specific phenomena that have puzzled observers since our visitor's arrival, we must remember that Earth exists not as an isolated island in space, but as an active participant in cosmic systems that operate according to principles as beautiful as they are profound, as delicate as they are powerful, and as immediate as they are eternal in their influence on the world we call home. In the early hours of April 14, 2025, photographers across the American Southwest began documenting something that challenged every textbook explanation of how aurora form and where they can appear. The Northern Lights, those ethereal dancers that had been confined for millennia to the polar regions, were painting the sky above Phoenix with curtains of light that rippled and flowed, in patterns that seemed to follow gravitational rhythms rather than magnetic field lines. The Great Aurora Expansion, as atmospheric physicists would later term it, represented a fundamental shift in the boundaries that had governed aurora activity throughout recorded history. Where previous displays had rarely appeared more than 60 degrees from the magnetic poles, the new aurora were manifesting 1,200 kilometers south of their traditional range, as if the invisible barriers that contained them had suddenly become permeable to forces that operated according to different rules. These were not the familiar green curtains that had inspired wonder in Arctic observers for thousands of years. Time-lapse photography revealed colours that had no precedent in aurora literature, deep purples that pulsed with the rhythm of distant music, silver streams that flowed like liquid mercury across the dome of the sky, and blues so intense they seemed to carry light from places where such hues had never before existed in Earth's atmosphere. Spectroscopic analysis of these anomalous displays revealed wavelengths that challenged fundamental understanding of how atmospheric gases respond to charged particle bombardment. Traditional aurora result from solar wind particles exciting oxygen and nitrogen at specific altitudes, creating the characteristic green glow of oxygen at 108 km altitude, and the red emissions that occur when the same atoms are excited at higher elevations where atmospheric density drops below critical thresholds. But the southern aurora displayed emission lines that corresponded to no known atmospheric constituents operating at any recognized altitude. Some displays showed spectral signatures suggesting the presence of elements that do not naturally occur in Earth's atmosphere, while others exhibited wavelength combinations that implied energy interactions far more complex than simple particle collision and excitation. The intensity measurements defied every model of aurora formation that atmospheric physicists had developed through decades of polar observation. Some displays reached KP9 levels, the highest classification on the geomagnetic activity scale, despite occurring during periods when solar monitoring satellites detected minimal coronal mass ejection activity and essentially quiet space weather conditions. Under normal circumstances, aurora of such intensity require massive solar storms that hurl billions of tons of charged particles toward Earth at velocities exceeding 800 km per second. These solar tempests create the kind of electromagnetic chaos that can disable satellites, disrupt radio communications, and induce electrical currents powerful enough to damage terrestrial power grids. Yet the anomalous aurora appeared during periods of solar minimum when our star's magnetic activity was at its quietest levels in decades. Duration presented another puzzle that challenged conventional aurora physics. Traditional displays typically last between 2 and 4 hours, as Earth's rotation carries observers through the zones where solar wind particles interact most efficiently with the magnetosphere. The southern aurora persisted for 14 to 18 hours, maintaining their intensity and colour throughout periods when normal displays would have faded into the background glow of dawn or the light pollution of human cities. Indigenous observers, whose cultural traditions included thousands of years of aurora watching, reported that these new displays moved according to patterns they had never seen before. Inuit elders in northern Canada described the lights as dancing to star visitor rhythms, while First Nation skywatchers noted that the aurora seemed to respond to the position of the bright object that had captured global attention, rather than following the familiar magnetic field patterns that had governed their movement since time immemorial. Photographic analysis revealed movement patterns that followed non-terrestrial geometries, with light structures that curved and flowed according to mathematical principles that appeared to have more in common with orbital mechanics than with the electromagnetic processes that typically govern aurora formation. Time-lapse sequences showed aurora formations that spiraled in patterns matching our cosmic visitor's rotation period, as if the lights themselves were responding to gravitational or electromagnetic influences originating beyond Earth's atmosphere. The atmospheric chemistry implications of these displays extended far beyond their visual impact. Upper atmosphere monitoring stations detected increased ionization levels in regions where the anomalous aurora appeared, suggesting that whatever processes created the lights were also affecting the chemical composition and electrical properties of the atmosphere at altitudes where such changes could influence everything from radio propagation to ozone formation. The correlation between aurora appearances and our visitor's orbital position became impossible to ignore as observations accumulated throughout the spring and summer of 2025. Peak aurora activity occurred not during periods of high solar activity, as traditional models predicted, but when our wandering mountain reached specific positions relative to Earth's magnetosphere, particularly during moments when its trajectory aligned with the direction of the solar wind flow. The heliosphere disturbance theory emerged from attempts to explain how an object travelling through interplanetary space might affect aurora formation on Earth. The heliosphere, that vast bubble of charged particles surrounding our solar system, extends far beyond the orbit of Pluto and represents the boundary between solar and interstellar environments. A massive object moving through this region at high velocity would create disturbances analogous to the wake behind a ship, potentially focusing solar wind particles into concentrated streams. Computer modelling of our visitor's trajectory through the heliosphere revealed that its passage would have created pressure waves and particle density variations that could propagate across the solar system at velocities approaching the solar wind speed. These disturbances, upon reaching Earth's vicinity, could have created the kind of enhanced particle bombardment necessary to generate aurora at latitudes where the magnetic field normally provides adequate protection against solar wind infiltration. The magnetosphere resonance hypothesis suggested an even more exotic mechanism for aurora enhancement. If our cosmic visitor possessed significant electromagnetic properties, as suggested by its anomalous glow and apparent technological capabilities, its movement through space could have generated electromagnetic oscillations that harmonized with Earth's natural magnetic field variations. Earth's magnetosphere oscillates with characteristic frequencies that range from seconds to hours, creating standing wave patterns that can amplify electromagnetic disturbances under specific conditions. If our visitor's electromagnetic signature operated at frequencies that matched these natural resonance modes, even weak signals could have been amplified into powerful disturbances capable of creating aurora where none should have been possible. The historical parallel of the Carrington event provided a framework for understanding how electromagnetic disturbances could create aurora at unprecedented latitudes. During that famous solar storm of 1859, aurora appeared as far south as the Caribbean. Telegraph systems sparked and failed across 2 continents, and the northern lights were so bright that people could read newspapers by their glow in Boston and other temperate cities. But the Carrington event required a solar storm of extraordinary magnitude, with coronal mass ejections that carried more energy than humanity's entire nuclear arsenal. The aurora associated with our visitor's passage occurred during periods of solar quiet, suggesting electromagnetic enhancement mechanisms that operated according to principles more sophisticated than simple particle bombardment of the upper atmosphere. The amplification effect could explain not only the unusual latitudes where aurora appeared, but also their extraordinary duration and intensity. If our visitor's passage created standing wave patterns in the magnetosphere that persisted beyond its immediate presence, these electromagnetic structures could have continued channeling solar wind particles toward Earth long after the object itself had moved to more distant regions of the solar system. Radio interference patterns provided additional evidence for electromagnetic enhancement of aurora activity. Traditional aurora create radio blackouts in specific frequency ranges that correspond to the energy levels of the charged particles responsible for the light displays. The anomalous aurora were accompanied by radio disruptions that extended across frequency ranges never before associated with aurora activity, suggesting energy interactions that operated according to principles beyond conventional atmospheric physics. Satellite data revealed charged particle concentrations that followed patterns matching our visitor's orbital trajectory rather than the spiral paths typically associated with solar wind interactions. These particle streams appeared to maintain their organization across distances measured in millions of kilometers, as if some mechanism were focusing and directing them with precision that exceeded anything observed in natural solar wind phenomena. The cascade hypothesis suggested that aurora formation represented only the most visible aspect of atmospheric changes that rippled through multiple layers of Earth's gaseous envelope. Enhanced ionization in the upper atmosphere could affect chemical reaction rates, ozone formation and destruction, and the electrical properties of atmospheric layers that influence everything from lightning formation to radio wave propagation. These atmospheric changes, once initiated, could persist for weeks or months through feedback mechanisms that operated independently of the original triggering events. Altered atmospheric chemistry could affect cloud formation patterns, which influence regional climate, which modifies atmospheric circulation, which affects the distribution of charged particles, which influences aurora formation in a self-sustaining cycle that maintains anomalous conditions long after their initial trigger has departed. The electromagnetic signature of our cosmic visitor, revealed through its impossible glow and trajectory modifications, suggested technological capabilities that included precise control over electromagnetic field generation and manipulation. If such control extended to influencing planetary magnetospheres, the enhanced aurora activity could represent a deliberate demonstration of capability rather than an accidental side effect of proximity. This interpretation transformed the aurora displays from curious atmospheric phenomena into potential communications, with the lights themselves serving as a form of electromagnetic semaphore that operated on planetary scales. The unusual colours, extended duration, and non-terrestrial movement patterns could represent encoded information designed to be noticed and analysed by observers capable of sophisticated spectroscopic and mathematical analysis. The traditional role of aurora in human culture, spanning from ancient mythology to modern scientific investigation, provided context for understanding why such phenomena might be chosen as communication media. Aurora have always represented the intersection between terrestrial and cosmic forces, visible evidence that our planet exists in constant dialogue with influences that originate beyond our atmosphere. Indigenous cultures across the circumpolar regions have long interpreted aurora as messages from celestial beings, with specific colours and movement patterns carrying distinct meanings that were preserved in oral traditions spanning millennia. The appearance of aurora at latitudes where such phenomena had never been observed could represent an expansion of this cosmic communication system to include observers who had been excluded from the traditional dialogue between sky and Earth. As spring turned to summer and the anomalous aurora continued to appear across temperate skies, the growing body of observational data suggested that Earth's atmosphere was responding to influences that operated according to principles more sophisticated than simple charged particle bombardment. The lights that painted impossible colours across familiar skies spoke of forces that could reach across the vacuum of space to touch the very chemistry of our world. The skies had learned to burn with new fires, colours that carried information from places beyond the familiar boundaries of solar system dynamics. Each display added to a growing catalogue of evidence that our cosmic visitor had left its mark not just in the memories of those who watched its passage, but in the fundamental behaviour of atmospheric systems that would continue to whisper of its presence long after its glow had faded beyond the limits of human detection. In the shifting colours that danced across southern skies, observers began to recognise the signature of intelligence that spoke in the language of electromagnetic manipulation, demonstrating capabilities that transcended the familiar physics of solar wind and magnetic field interaction to create aurora that served as both phenomenon and message, both natural wonder and technological demonstration of powers that operated on scales and according to principles that human science was only beginning to recognise and understand. Deep beneath our feet, in the churning metallic heart of our planet, something extraordinary began to happen during the months when our cosmic visitor traced its impossible path through the inner solar system. The magnetic field that has protected Earth for billions of years, that invisible shield which deflects cosmic radiation and guides countless species in their migrations across land and sea, started speaking in whispers that carried accents from beyond our world. The North Magnetic Pole, that wandering point toward which every compass needle has faithfully turned since humans first learned to navigate by magnetism, suddenly accelerated its drift across the Arctic Ocean with an urgency that geophysicists had never before recorded. Where this invisible landmark had been moving at its historically steady pace of 55 kilometers per year, it surged to 73 kilometers annually, an increase of 30% that coincided precisely with our visitor's closest approach to the Sun. This acceleration was not the gentle, predictable drift that characterizes normal magnetic pole movement, driven by the slow convection of the molten iron in Earth's outer core. This was an abrupt change in direction and velocity that suggested external forces were influencing the fundamental processes that generate our planet's magnetic field, reaching down through thousands of kilometers of solid rock and liquid metal to touch the very mechanism that creates the magnetosphere protecting all life on Earth. Local magnetic field strength began fluctuating with a regularity that matched no known terrestrial cycle. Magnetometer stations across the globe detected variations of plus or minus 3% in magnetic intensity occurring in precise 24-hour cycles during our visitor's closest approach, as if the planet's magnetic field were breathing in rhythm with some cosmic influence that operated according to its own temporal logic. Navigation instruments around the world began reporting compass declination shifts that challenged the mathematical models used to correct for magnetic variation. Ships at sea found their compasses pointing to positions that deviated from calculated magnetic north by margins that exceeded instrument error tolerances. Aircraft navigation systems registered magnetic heading errors that required constant correction during the period when our cosmic wanderer dominated the skies above the ecliptic plane. The South Atlantic anomaly, That region above the South Atlantic Ocean where Earth's magnetic field weakness allows dangerous levels of cosmic radiation to penetrate closer to the surface, began expanding during our visitor's passage through the southern celestial hemisphere. This zone of magnetic vulnerability, which typically remains stable for decades at a time, grew by approximately 8% in area, creating navigation hazards for aircraft and increased radiation exposure for satellites passing through the affected region. 247 magnetometer stations forming a global monitoring network detected coordinated magnetic pulses that propagated across the planet's surface at precise intervals, matching our visitor's 7.3-hour rotation period. These pulses were not random fluctuations, but organized waves of magnetic field variation that swept around the globe like the beam of a lighthouse, suggesting that our wandering mountain was somehow broadcasting electromagnetic signals strong enough to influence planetary-scale magnetic phenomena. The Van Allen radiation belts, those donut-shaped zones of charged particles trapped by Earth's magnetic field, began exhibiting trajectory patterns that defied conventional models of particle motion in magnetospheric environments. Satellites equipped with radiation detectors recorded particle streams, following orbital paths that appeared to be influenced by gravitational or electromagnetic forces originating beyond Earth's atmosphere, as if the familiar architecture of our planet's radiation environment were being reshaped by external influences. Animal navigation systems evolved over millions of years to exploit the precise stability of Earth's magnetic field, began showing signs of confusion that coincided with our visitor's transit. Migratory birds released during traditional banding studies flew in directions that deviated from their normal routes by margins that exceeded any variation recorded in decades of ornithological research. Sea turtles, whose navigation abilities depend on detecting minute variations in magnetic field strength, were found swimming in patterns that suggested their biological compasses were responding to magnetic signatures that had no precedent in their evolutionary experience. Arctic terns, those master navigators that travel from Arctic to Antarctic and back again each year following magnetic field lines with precision that rivals GPS technology, began arriving at traditional roosting sites days or weeks off their normal schedule. Whale populations showed similar navigation disruption, with pods appearing in waters where magnetic conditions should have guided them to entirely different regions of the ocean. The dynamo theory that explains Earth's magnetic field generation describes how the rotation of our planet, combined with convection currents in the liquid outer core, creates the electrical currents responsible for magnetosphere formation. This process operates according to principles so fundamental that magnetic field variations typically occur over timescales measured in thousands or millions of years, driven by changes in core composition or planetary rotation rate that require geological ages to manifest. Yet the magnetic anomalies associated with our visitor's passage suggested that external gravitational influences could affect core convection patterns on timescales measured in months rather than millennia. Computer models of outer core fluid dynamics revealed that massive objects passing through the inner solar system could create tidal forces sufficient to alter the flow patterns of liquid iron at depths exceeding 2,000 kilometers below Earth's surface. These models indicated that gravitational gradients created by our visitor's proximity would have generated differential forces across Earth's diameter, with one side of the planet experiencing slightly stronger attraction than the other. While such forces would be imperceptible at the surface, they could create measurable effects in the fluid outer core, where convection currents operate according to extremely sensitive pressure and temperature gradients. Historical magnetic declination records preserved in medieval monastery archives and maritime navigation logs provided evidence that similar magnetic anomalies had occurred during previous periods when guest stars appeared in Earth's skies. Compass readings recorded during the Tang Dynasty guest star events of the 8th and 9th centuries showed magnetic deviations that paralleled the patterns observed during our visitor's transit, suggesting that the phenomenon represented a recurring pattern rather than an unprecedented event. Archaeological magnetism, the study of magnetic field directions preserved in ancient pottery and volcanic rocks, revealed additional evidence of magnetic anomalies that coincided with historical celestial events. Pottery kilns that fired during periods when Chinese astronomers recorded unusual celestial visitors showed magnetic orientations that deviated from expected values, by margins consistent with the field variations observed during our cosmic wanderer's passage. The gravitational coupling between our visitor's enormous mass and Earth's molten outer core represented a mechanism by which external objects could influence internal planetary processes across distances that seemed impossibly vast. Tidal forces operate according to the inverse cube of distance, meaning that as our wandering mountain approached its closest point to Earth, its gravitational influence would have increased dramatically, reaching levels sufficient to affect fluid motion in the planet's deep interior. Electromagnetic induction provided another pathway through which our visitor's passage could have influenced Earth's magnetic field. A massive, electrically charged object moving at high velocity through space generates electromagnetic fields that propagate outward at light speed, creating disturbances that can induce currents in any conductive material they encounter. Earth's outer core, composed primarily of liquid iron and nickel, represents an enormous electrical conductor that responds to electromagnetic fields, according to principles described by Faraday's law of induction. If our cosmic visitor possessed the electrical charge suggested by its anomalous luminosity and apparent technological capabilities, its movement through the inner solar system would have generated electromagnetic pulses capable of inducing temporary current patterns in the planet's core. The resonance factor became apparent when researchers analysed the frequency characteristics of the magnetic disturbances associated with our visitor's passage. Earth's magnetic field oscillates naturally with a fundamental period of approximately 11.5 seconds, creating standing wave patterns that can amplify electromagnetic disturbances when they occur at matching frequencies. Our wandering mountain's 7.3-hour rotation period produced electromagnetic variations that, when subjected to harmonic analysis, revealed frequency components that aligned precisely with Earth's magnetic field resonance modes. This harmonic matching could have amplified relatively weak electromagnetic signals into disturbances powerful enough to affect global magnetic field behavior through resonance coupling effects. Ionospheric coupling represented yet another mechanism linking our visitor's electromagnetic influence to surface magnetic measurements. The ionosphere, that layer of charged particles in the upper atmosphere, serves as a conductive boundary that couples electromagnetic phenomena occurring above the atmosphere to magnetic field variations detectable at Earth's surface. Changes in ionospheric conductivity, caused by enhanced charged particle bombardment during our visitor's passage, could have altered the way electromagnetic disturbances propagated between the upper atmosphere and the ground, creating magnetic field variations that appeared to originate from within Earth, but actually reflected external electromagnetic influences transmitted through the ionospheric boundary layer. The protection hypothesis suggested that the magnetic field fluctuations represented Earth's attempt to shield itself from unknown influences, with the planet's magnetic field system responding adaptively to external electromagnetic or gravitational disturbances. Under this interpretation, the observed magnetic anomalies reflected not passive response to external forces, but active protection mechanisms operating on planetary scales. This hypothesis found support in the observation that magnetic field disturbances were strongest in regions where our visitor's trajectory would have created maximum gravitational or electromagnetic influence, as if Earth's magnetic field were concentrating its protective effects in areas of greatest external stress. Deep Earth sensitivity became apparent through analysis of how surface magnetic changes correlated with seismic activity and other geological phenomena occurring during our visitor's transit. The magnetic field variations appeared to presage earthquake activity and volcanic eruptions by margins that suggested causal relationships between electromagnetic disturbances and deep Earth processes. These correlations implied that magnetic field fluctuations served as early warning signals for geological activity, revealing connections between electromagnetic phenomena and tectonic processes that operated through mechanisms more sophisticated than simple correlation or coincidence. Medieval compass records provided historical context for understanding magnetic anomalies as recurring phenomena associated with celestial visitors. Navigation logs from the Age of Exploration documented compass deviations that occurred during periods when European chroniclers recorded unusual celestial events, suggesting that magnetic field disturbances had affected navigation throughout human history, without being recognised as connected to astronomical phenomena. The timing precision of magnetic disturbances, occurring at intervals that matched our visitors' orbital characteristics with mathematical exactness, eliminated the possibility of coincidental correlation and demanded recognition of causal mechanisms that operated across the vast distances of interplanetary space. As summer progressed, the magnetic monitoring stations continued recording anomalous readings that followed patterns established during our visitors' closest approach. The evidence became overwhelming that Earth's magnetic field had been fundamentally altered by contact with intelligence that possessed the capability to influence planetary-scale electromagnetic phenomena. The magnetic field that protects our world had learned to dance to rhythms that originated beyond our atmosphere, carrying information encoded in fluctuations that spoke of technologies capable of reaching across the vacuum of space to touch the very heart of our planet's protective systems. Earth's magnetic heartbeat now carried accents from the space between stars, whispering of visitors who possessed the wisdom and capability to influence the fundamental forces that govern planetary magnetic field generation, demonstrating that the boundaries between terrestrial and cosmic phenomena were far more permeable than human science had ever imagined possible. On the morning of July 19, 2025, seismograph stations across Central Australia registered something that geology textbooks insisted could not happen. A magnitude 5.2 earthquake struck the heart of the outback, shaking ground that had remained tectonically stable for more than 50 million years, awakening bedrock that had slept undisturbed since the age of dinosaurs first walked the Earth. This was not simply an unusual earthquake. This was an impossibility made manifest, a tremor that occurred in geological conditions where the movement of continental plates creates so little stress that major seismic events are predicted to occur perhaps once every several million years. The Australian Craton, that ancient core of stable continental crust, represents one of the most seismically quiet regions on our planet, a place where the solid Earth maintains the kind of profound stillness that characterizes geological structures billions of years old. Yet here, in the red center of a continent that has known geological peace since before multicellular life evolved in Earth's oceans, the ground shook with force sufficient to be felt across hundreds of kilometers, creating seismic waves that propagated through bedrock as ancient as any formation on our planet's surface. The Australia anomaly, as seismologists would later term it, represented only the most dramatic example of a pattern that had been emerging across the globe throughout the period of our cosmic visitors' transit through the inner solar system. 23 earthquakes of magnitude 4.0 or greater had struck regions classified by geological surveys as tectonically stable, areas where the slow dance of continental drift creates insufficient stress to trigger significant seismic activity under normal circumstances. These were not random events scattered across geological time, but clustered occurrences that followed a temporal pattern so precise it challenged every assumption about how earthquake timing relates to tectonic processes. The seismic events correlated with our visitors' orbital position at 6-hour intervals, creating a rhythm that matched the rotation period of our wandering mountain with mathematical exactness that eliminated any possibility of coincidental timing. Intraplate earthquakes, those rare tremors that occur within the stable interiors of continental masses rather than along the active boundaries where tectonic plates meet and grind against each other, typically result from stress accumulation that requires thousands or millions of years to reach critical thresholds. The sudden clustering of such events during our visitors' passage suggested external forces capable of triggering seismic release in regions where geological stress should have been insufficient to support earthquake activity. The timing precision of these seismic events revealed patterns that had no precedent in earthquake literature. Traditional seismic activity follows the chaotic rhythms of tectonic stress accumulation and release, creating earthquake sequences that appear random when analysed on human timescales, but show statistical regularities only when examined across geological periods spanning millions of years. The earthquakes associated with our visitors' passage operated according to different principles entirely, occurring at intervals that could be predicted based on astronomical rather than geological calculations. This suggested that whatever forces triggered these seismic events originated beyond Earth's surface and operated according to gravitational or electromagnetic influences that reached deep into the planet's crust and upper mantle, tidal stress theory provided the most plausible mechanism for explaining how an object travelling through interplanetary space might trigger earthquake activity on Earth. Just as the Moon's gravity creates tidal bulges in the oceans, massive objects passing near our planet generate gravitational forces that stretch and compress the solid Earth itself, creating stress patterns that can accumulate and release through earthquake activity. The mathematics of gravitational influence reveal that tidal forces increase dramatically as objects approach closer to Earth, following an inverse cube relationship that means small changes in distance create enormous changes in gravitational stress. During our visitor's closest approach, its gravitational influence would have created differential forces across Earth's diameter sufficient to generate measurable crustal deformation in regions where geological stress levels approached critical thresholds. Computer modelling of gravitational gradient effects showed that our wandering mountain's 2.1 billion ton mass, moving at velocities exceeding 26 km per second, would have generated tidal forces comparable to those created by lunar gravitational influence, but concentrated into much shorter time periods and focused along different directional vectors than the familiar north-south tidal patterns created by Moon and Sun. Deep focus earthquakes, those rare seismic events that originate at depths exceeding 400 kilometers within Earth's upper mantle, began occurring with unusual frequency during our visitor's transit period. These deep tremors, which typically result from mineral phase transitions or convection-related stress in the mantle, suggested that external gravitational influences were affecting geological processes far below the surface regions where most earthquake activity originates. The correlation between deep focus earthquake timing and our visitor's orbital position implied that gravitational forces were propagating through the entire solid Earth, affecting stress patterns and mineral stability at depths where temperatures exceed 1000 degrees Celsius and pressures crush rock into crystalline forms unknown at surface conditions. Volcanic activity monitoring stations detected coordinated increases in seismic activity at Mount Etna, Stromboli, and Kilauea during periods when our cosmic wanderer reached specific orbital positions relative to Earth's position in its solar orbit. These volcanic systems, separated by thousands of kilometers and operating according to independent magma supply and eruption cycles, showed statistical correlations in their activity levels that suggested external influences affecting global volcanic processes. The mechanism underlying such correlations likely involved the same tidal stress effects that triggered earthquake activity in stable continental regions. Volcanic systems represent zones where molten rock approaches close enough to Earth's surface to create conditions sensitive to minute changes in gravitational stress, with even tiny increases in tidal force capable of triggering eruptions in magma chambers that have reached critical pressure thresholds. Groundwater monitoring networks across multiple continents detected synchronized fluctuations in well levels that matched our visitor's orbital position with the same mathematical precision observed in earthquake timing and magnetic field variations. These hydrological changes occurred simultaneously across vast geographical distances, suggesting that gravitational influences were affecting subsurface water movement through mechanisms that operated faster than the flow rates that typically govern groundwater systems. The groundwater correlations implied that our visitor's gravitational field was creating pressure waves that propagated through Earth's crust at velocities approaching seismic wave speeds, generating stress patterns that affected not only solid rock formations, but also the fluid systems that flow through fractures and pore spaces within geological formations. Microtremor analysis revealed seismic vibrations below the threshold of human perception that followed patterns matching our wandering mountain's rotational characteristics. Seismograph arrays equipped with sensors capable of detecting ground motion measured in nanometers recorded coordinated oscillations that swept across continental surfaces like waves, suggesting that our visitor's passage was exciting vibrational modes that affected the entire solid Earth. The resonance mechanism underlying these microtremors operated according to principles similar to those that govern musical instrument acoustics, with our planet responding to external gravitational influences like a vast, complex resonator excited by cosmic forces operating at frequencies that matched Earth's natural vibrational modes. Earth's free oscillation periods, ranging from 20 to 54 minutes, represent the planet's natural response to large-scale disturbances, such as major earthquakes or meteorite impacts. These fundamental frequencies characterize how our planet vibrates as a complete system when subjected to sudden energy inputs, creating standing wave patterns that can persist for days or weeks after their initial triggering events. Our visitor's passage appeared to be exciting these free oscillation modes through gravitational coupling effects that operated continuously rather than through single impulsive events. This sustained excitation could explain both the unusual duration of seismic anomalies and their correlation with astronomical rather than geological timing patterns. Historical earthquake records preserved in Chinese and Japanese chronicles provided evidence that similar seismic anomalies had occurred during previous periods when celestial visitors appeared in Earth's skies. The devastating Antioch earthquake of 526 CE, which destroyed one of the largest cities in the Byzantine Empire, occurred within months of Chinese astronomical records describing a star that moved against heaven's order. The correlation between historical earthquake activity and astronomical events suggested that the phenomenon represented a recurring pattern, rather than an unprecedented occurrence, with Earth's seismic systems responding to cosmic influences according to principles that had operated throughout human history, but remained unrecognized by geological science focused on terrestrial processes. Mayan chronological records linking the return of Kukulkan, the feathered serpent deity associated with celestial cycles, to periods of Earth serpent awakening, provided additional evidence that ancient civilizations recognized connections between astronomical events and seismic activity. These mythological accounts, when analyzed through the lens of modern seismology and astronomical dating, revealed correlations between major earthquake periods and celestial events that paralleled the patterns observed during our visitor's transit. Atmospheric loading effects represented another mechanism through which our cosmic wanderer might have influenced earthquake timing and intensity. Changes in atmospheric pressure, caused by gravitational or electromagnetic influences on atmospheric circulation patterns, create loading and unloading stress on Earth's surface that can affect earthquake timing in regions where tectonic stress approaches critical levels. Ocean tide amplification provided yet another pathway for cosmic influences to affect terrestrial seismic activity. Enhanced tidal forces created by our visitor's gravitational field would have generated larger than normal ocean tides, creating cyclical loading stress on coastal fault systems that could advance the timing of earthquake activity in seismically active coastal regions. The solid Earth tide, that vertical movement of continental surfaces in response to gravitational influences from Moon and Sun, reached amplitudes exceeding 30 centimeters during our visitor's closest approach. This represents deformation sufficient to affect stress patterns in fault systems and volcanic conduits, creating conditions that could trigger earthquake and eruption activity in geological systems approaching critical stress thresholds. Stress transfer mechanisms operating through Earth's lithosphere provided pathways for gravitational disturbances to propagate across vast distances, affecting seismic activity in regions far removed from the direct influence of our visitor's gravitational field. These mechanisms operate according to principles similar to those that govern earthquake triggering by large seismic events, with stress changes propagating through interconnected fault networks to affect earthquake timing across continental scales. Ancient geological records preserved in rock formations and sedimentary deposits provided evidence of seismic events that coincided with astronomical phenomena throughout Earth's geological history. Tsunami deposits, landslide scars, and other geological markers of major earthquake activity showed statistical correlations with impact crater dating and other evidence of cosmic events, suggesting that the relationship between celestial and terrestrial phenomena extended far beyond recorded human history. The growing body of evidence linking seismic activity to our visitor's passage painted a picture of Earth as a dynamic, responsive system that maintains constant dialogue with cosmic influences through gravitational, electromagnetic, and perhaps other mechanisms that operate according to principles more sophisticated than traditional geology acknowledges. The ground beneath our feet, that apparently solid foundation upon which human civilization has built its cities and cultures, revealed itself to be sensitive to influences that originate in the space between stars, recording the passage of cosmic visitors in tremors and earthquakes that speak of forces capable of reaching across vast distances to touch the very foundations of our world. In learning to listen to these seismic whispers, we begin to understand that the boundaries between Earth and space, between terrestrial and cosmic phenomena, between geological and astronomical timescales, are far more permeable than our science has traditionally acknowledged, opening new perspectives on our planet's place in a universe where every visitor leaves its signature written in stone, recorded in the ancient memory of rock formations that remember every cosmic touch across the vast expanse of geological time. Long before seismographs could detect the whisper of distant earthquakes or magnetometers could measure the subtle fluctuations of our planet's magnetic field, human observers were recording correlations between celestial events and terrestrial upheavals that modern science has only recently begun to recognize as potential evidence of cosmic terrestrial connections. These ancient accounts, preserved in cuneiform tablets, court chronicles, and oral traditions spanning millennia, speak of a universe where the boundaries between sky and earth were far more permeable than our current understanding acknowledges. The Epic of Gilgamesh, that ancient masterpiece of Mesopotamian literature, contains within its mythological narrative what may be humanity's oldest written account of cosmic visitors triggering terrestrial catastrophe. The tablets describe how wandering star Marduk appeared in the heavens before the Great Deluge, moving against the fixed patterns of celestial order in ways that presaged the flooding that would reshape the world and test the survival of all living things. The Aridogenesis, dating from approximately 2,100 years before the Common Era, provides even more specific details about the relationship between celestial anomalies and earthly destruction. This Sumerian creation account describes how a heaven star caused the ground to tremble and waters to rise beyond their boundaries, linking the appearance of unusual celestial objects directly to seismic and hydrological disasters that affected the entire known world. These ancient Mesopotamian accounts gain additional significance when analysed alongside modern geological evidence for major flooding events in the Tigris-Euphrates river system during the 3rd millennium BCE. Sedimentary deposits from this period show evidence of catastrophic floods that correlate temporally with astronomical records of unusual celestial events, suggesting that the mythological accounts may preserve genuine observations of cosmic terrestrial connections. Chinese earthquake catalogues, maintained with meticulous precision by court astronomers for over 3,000 years, reveal statistical patterns that challenge conventional understanding of seismic activity as purely terrestrial phenomena. Han Dynasty records spanning from 206 years before the Common Era to 220 CE document systematic correlations between guest star appearances and major earthquake activity throughout the empire. The most thoroughly documented case appears in the chronicles of Emperor Ling, which describe how the Broom Star appeared in the constellation Altair during the year 186 CE, remaining visible for 7 months while displaying unusual movement patterns that court astronomers carefully tracked and recorded. Within 18 months of this celestial visitor's departure, a devastating earthquake destroyed the capital city of Luoyang, killing an estimated 240,000 people and fundamentally altering the political landscape of the empire. The correlation between celestial events and seismic disasters appears repeatedly throughout Chinese historical records, with major earthquakes following astronomical anomalies at intervals that suggest causal rather than coincidental relationships. Court astronomers of the Tang dynasty developed prediction methods based on these correlations, using celestial observations to forecast periods of increased earthquake risk with accuracy that exceeded random chance by statistically significant margins. Japanese historical seismology, preserved in court records and monastery chronicles spanning over 14 centuries, provides additional evidence for cosmic terrestrial connections that transcend cultural interpretation. The Nihon Sandai Jitsuroku, compiled during the 9th century, documents how the appearance of a guest star in 1181 CE preceded the devastating Kamakura earthquake by exactly 2 years and 4 months, suggesting that ancient observers had identified specific time intervals between celestial events and their terrestrial consequences. The precision of these temporal correlations becomes even more remarkable when viewed alongside modern astronomical research that has identified the 1181 CE guest star as a supernova explosion in the constellation Cassiopeia. Chinese and Japanese astronomers independently recorded this stellar explosion, noting its unusual brightness, colour variations and duration, before correlating its appearance with subsequent earthquake activity that affected multiple regions of the Japanese archipelago. The preservation of such detailed observational records across multiple independent cultures suggests that ancient astronomers possessed sophisticated understanding of cosmic terrestrial relationships that modern science has only recently begun to acknowledge. These were not primitive observers imposing supernatural explanations on random events, but careful scientific investigators documenting patterns that operated according to consistent principles across geographical and cultural boundaries. Hopi prophecy traditions, preserved through oral transmissions spanning thousands of generations, speak of the blue star Kachina, whose dance in the sky will trigger a period when Earth will shake and waters will rise beyond their boundaries. The prophecy describes this celestial visitor as appearing during times of great transformation, when the old ways give way to new realities, and the fundamental structure of the world shifts in response to cosmic influences. The Hopi geological memory, encoded in ceremonial practices and landscape relationships that may extend back 10,000 years or more, preserves detailed knowledge of correlations between celestial events and terrestrial changes that include specific information about earthquake timing, volcanic activity, and hydrological disruptions. This traditional knowledge system operates according to principles that recognize sky-Earth connections as fundamental aspects of planetary dynamics, rather than supernatural interventions in natural processes. Archaeological dating of Hopi settlement patterns reveals correlations between community relocations and astronomical events that suggest practical application of celestial terrestrial knowledge for predicting and preparing for geological hazards. The placement of ceremonial sites and agricultural areas appears to follow principles that take into account the relationship between astronomical cycles and seismic risk, indicating sophisticated understanding of cosmic influences on geological stability. Norse mythology preserves accounts of cosmic events triggering terrestrial transformation in the prophetic poem Völuspá, which describes celestial signs that will precede Ragnarok, the transformation of the world. The poem speaks of stars falling from their courses, the earth quaking, and mountains falling in response to cosmic disturbances that operate according to cyclical principles spanning vast temporal scales. Archaeological evidence from Scandinavian sites suggests that Norse astronomical knowledge included sophisticated techniques for correlating celestial events with geological phenomena. Stone circles, burial alignments, and seasonal celebration sites show clear evidence of astronomical observation capabilities that could have supported the kind of detailed sky-Earth correlation described in mythological accounts. The Völuspá describes specific sequences of events linking astronomical anomalies to terrestrial upheavals, including detailed timing relationships that suggest empirical observation rather than purely imaginative construction. The poem's description of earthquakes and mountains falling in response to stellar disturbances parallels modern understanding of how gravitational and electromagnetic influences from cosmic sources might affect terrestrial geological systems. Celtic Druidic records, preserved in archaeological evidence and later medieval transcriptions, indicate that ancient Celtic astronomical knowledge included specific techniques for tracking earth-shaking stars and predicting their effects on local geological conditions. Stone circle alignments across Britain and Ireland show evidence of astronomical observation systems designed to monitor celestial events that were believed to influence terrestrial stability. The precision of these astronomical alignments suggests that Celtic observers possessed mathematical and engineering capabilities sufficient to construct prediction systems for cosmic terrestrial correlations. The investment of enormous labour and resources in these astronomical monuments indicates that sky-Earth connections were considered matters of practical rather than purely ceremonial significance. Mayan astronomical records, preserved in codices that survived Spanish colonial destruction, contain mathematical tables correlating Venus cycles with seismic and volcanic activity throughout Mesoamerica. The Dresden Codex includes specific calculations linking Venus inferior conjunction events to increased earthquake risk, suggesting that Mayan astronomers had identified statistical relationships between planetary motions and geological phenomena. The mathematical sophistication of these correlations, involving complex calculations of planetary positions and timing intervals, indicates that Mayan astronomical knowledge operated according to empirical rather than purely mythological principles. The correlation table suggests systematic observation and analysis of cosmic terrestrial relationships spanning centuries of careful data collection and mathematical refinement. Aztec chronicles describe how appearances of Tezcatlipoca, the smoking mirror star, were linked to major earthquake activity in the region around Teotihuacan. Archaeological evidence for seismic damage at Teotihuacan correlates temporally with Aztec astronomical records, suggesting that these accounts preserve genuine observations of cosmic terrestrial connections, rather than purely symbolic religious narratives. Egyptian astronomical papyri, including texts found in pyramid burial chambers and temple libraries, describe Sobek star events that caused the land to shudder throughout the Nile Valley. These accounts include specific timing relationships between stellar appearances and seismic activity that parallel the patterns observed in Chinese and Japanese records, suggesting cross-cultural recognition of similar cosmic terrestrial phenomena. The precision of Egyptian astronomical knowledge, demonstrated through pyramid alignments and calendar systems that operated with accuracy exceeding many modern calculations, indicates that correlations between celestial events and terrestrial phenomena were based on sophisticated observational capabilities rather than superstitious interpretation of random events. Biblical earthquake records provide additional evidence for ancient recognition of cosmic terrestrial connections. The Book of Amos describes a major earthquake that occurred 2 years before the star, providing specific timing information that has been correlated with astronomical events recorded in Assyrian and Babylonian chronicles. Modern astronomical calculations indicate that this earthquake occurred in 760 BCE, coinciding with the appearance of a bright comet or stellar explosion recorded by multiple ancient civilizations. Islamic astronomical texts from the Golden Age preserve perhaps the most scientifically sophisticated ancient descriptions of cosmic terrestrial correlations. The astronomer al-Biruni, working in 11th century Persia, documented systematic observations of relationships between celestial events and ground motion, developing mathematical methods for analysing these correlations that anticipate modern statistical approaches to seismic prediction. Al-Biruni's methods included careful timing measurements, magnitude estimates, and geographical distribution analysis that allowed him to identify patterns linking astronomical events to earthquake activity across the Islamic world. His calculations suggested that certain types of celestial visitors produce seismic effects that followed predictable temporal and spatial patterns, indicating underlying physical mechanisms rather than random correlation. Australian Aboriginal Dreamtime accounts, preserved in oral traditions that may span 50,000 years or more, speak of sky serpents that cause earth sickness when they travel across the heavens. These accounts describe specific relationships between celestial movements and terrestrial disturbances that include detailed knowledge of earthquake timing, groundwater changes, and animal behaviour modifications. The temporal depth of Aboriginal astronomical knowledge, potentially extending back to the last ice age, provides unique perspective on cosmic terrestrial relationships spanning geological timescales. The consistency of these oral traditions across isolated Aboriginal groups suggests systematic observation and transmission of knowledge about sky-Earth connections that operated according to consistent principles across vast geographical and temporal scales. Statistical analysis of historical earthquake records in relation to documented celestial events reveals that 67% of major seismic disasters throughout recorded history were preceded by astronomical anomalies within timeframes ranging from months to several years. This correlation exceeds statistical significance thresholds and suggests systematic rather than coincidental relationships between cosmic and terrestrial phenomena. The cross-cultural consistency of these correlations, appearing in isolated civilizations that had no contact with each other, argues against their interpretation as purely mythological constructs. The technical precision of observational details, despite vast differences in cultural context and descriptive language, suggests that ancient astronomers were documenting genuine cosmic terrestrial connections that operated according to universal physical principles. Pattern recognition capabilities demonstrated by ancient astronomers included the development of prediction systems based on celestial observations, with several cultures achieving success rates in earthquake forecasting that exceeded random chance by margins that modern science would consider statistically significant. These prediction systems operated according to empirical rather than supernatural principles, suggesting that ancient observers had identified genuine causal relationships between astronomical and geological phenomena. Archaeological evidence supporting these historical accounts includes settlement abandonment patterns that correlate with astronomical event dating, construction techniques that account for seismic risk assessment based on celestial observations, and technological developments that suggest practical application of cosmic terrestrial knowledge for hazard mitigation and resource management. The accumulated weight of evidence from multiple independent cultures spanning thousands of years creates a compelling case that human civilization has long recognized connections between celestial visitors and terrestrial changes that modern science is only beginning to acknowledge and understand. Our ancestors knew what we have forgotten, that the sky and earth dance together in cosmic rhythms, and when strangers join the dance, the steps change in ways that affect every aspect of planetary dynamics, from magnetic field fluctuations to seismic activity to atmospheric chemistry. As we contemplate the correlations between our recent cosmic visitor and the cascade of terrestrial anomalies that have marked its passage, we must recognize that we are witnessing not an unprecedented event, but the latest iteration of a cosmic terrestrial dialogue that has been operating throughout human history, teaching each generation of observers that our world exists not in isolation, but as part of a vast interconnected system where every visitor from the space between stars leaves its mark, written in the patient memory of Earth's geological, magnetic and atmospheric systems. In the growing quiet that has followed our cosmic visitors' departure from the inner solar system, as aurora fade back to their polar realms and magnetic fields settle into familiar rhythms, we are left with a profound recognition that transforms our understanding of what it means to inhabit a world suspended in the vast darkness between stars. Earth, we have learned, exists not as an isolated island of life floating through empty space, but as an exquisitely sensitive participant in cosmic conversations that operate according to principles far more sophisticated and far-reaching than our science had ever imagined possible. The Gaia hypothesis, first proposed by scientist James Lovelock in the 1970s, envisioned our planet as an integrated system where biological, geological, atmospheric and oceanic processes work together to maintain conditions suitable for life. But the correlations we have observed between our visitor's passage and the cascade of terrestrial anomalies suggest something even more profound. Earth, as a conscious participant in galactic ecology, responsive to cosmic influences that extend far beyond the familiar gravitational effects of moon and sun. This expanded understanding transforms every aurora that painted impossible colours across temperate skies, every earthquake that awakened sleeping continental cores, every magnetic field fluctuation that sent compass needles dancing to new rhythms, into evidence of planetary sensitivity that operates on scales and according to principles that challenge the fundamental assumptions of terrestrial science. Systems theory, that mathematical framework for understanding how complex networks respond to external influences, provides language for describing how minor cosmic inputs can create cascading effects through the interconnected systems that govern planetary dynamics. Earth's atmosphere, hydrosphere, biosphere and geosphere operate as components of a single integrated network where changes in any domain propagate through feedback loops that can amplify small disturbances into system-wide transformations. The butterfly effect, popularized through chaos theory mathematics, demonstrates how systems characterized by sensitive dependence on initial conditions can amplify microscopic changes into macroscopic consequences. Earth's climate system exhibits exactly this kind of sensitive dependence, where tiny alterations in atmospheric temperature, pressure, or chemical composition can trigger shifts that affect weather patterns, ocean circulation, and ecological relationships across the entire planet. Our cosmic visitors' gravitational and electromagnetic influences, while seemingly minimal when compared to terrestrial energy budgets, operated on a planetary system that had evolved over billions of years to function within extremely narrow parameter ranges. Like a symphony orchestra where every instrument must maintain precise tuning to create harmonious music, Earth's interconnected systems require delicate balance, to sustain the conditions that support the extraordinary diversity of life that has flourished here for nearly 4 billion years. The gravitational influences that created tidal stresses in Earth's crust, the electromagnetic effects that enhanced aurora activity and disturbed magnetic field patterns, the resonance coupling that excited planetary vibration modes, all of these represent forms of cosmic input that our world had little evolutionary experience in managing. Earth's regulatory systems, evolved to handle the familiar rhythms of solar cycles and lunar tides, found themselves responding to influences that operated according to different temporal patterns and energy signatures. The planetary boundary layer, that thin interface between Earth's surface and the cosmic environment, serves as the medium through which external influences propagate into terrestrial systems. This boundary is far more permeable than traditional Earth science acknowledges, allowing gravitational waves, electromagnetic fields, charged particle streams, and other forms of cosmic influence to affect atmospheric chemistry, magnetic field dynamics, and even geological processes operating deep within the planet's interior. The magnetosphere, Earth's magnetic field extended into space, functions not just as a shield against cosmic radiation, but as a sensitive antenna system that detects and responds to electromagnetic disturbances originating across vast distances. The magnetic field fluctuations we observed during our visitors' transit represent not passive response to external forces, but active communication between planetary and cosmic electromagnetic systems operating on scales that dwarf human technological capabilities. Biogeochemical cycles, those planetary-scale processes that circulate carbon, nitrogen, phosphorus, and other essential elements through the biosphere, operate according to chemical and physical relationships that can be affected by cosmic influences on atmospheric and oceanic dynamics. Changes in magnetic field strength, aurora activity, and atmospheric chemistry cascade through these cycles, potentially affecting everything from plant growth patterns to oceanic productivity to the atmospheric composition that regulates global climate. The Anthropocene perspective, recognizing human civilization as a geological force capable of affecting planetary systems, adds another layer of complexity to understanding cosmic terrestrial interactions. Human modifications to atmospheric composition, land surface characteristics, and oceanic chemistry may have increased Earth's sensitivity to cosmic disturbances by altering the feedback mechanisms that maintain planetary stability. Industrial activities have changed atmospheric chemistry, creating new pathways for cosmic influences to affect terrestrial systems. The electromagnetic pollution generated by human technology may have amplified our planet's responsiveness to cosmic electromagnetic fields. The alteration of natural landscapes may have affected the way gravitational and seismic disturbances propagate through Earth's crust and upper mantle. Climate system sensitivity studies reveal how small changes in energy input can trigger large-scale reorganizations of atmospheric and oceanic circulation patterns. The enhanced aurora activity and magnetic field disturbances associated with our visitors' passage represent forms of energy input that, while tiny compared to solar heating, could have affected atmospheric chemistry and circulation patterns in ways that create long-term consequences for regional and global climate stability. Ocean circulation coupling provides another pathway through which cosmic influences can affect planetary systems, with implications that extend far beyond the immediate effects of gravitational or electromagnetic disturbances. Thermohaline circulation, the global conveyor belt of ocean currents driven by temperature and salinity differences, responds to changes in atmospheric conditions, magnetic field variations, and even subtle alterations in gravitational fields that affect tidal patterns and sea level variations. The Holocene stability that has characterized Earth's climate for the past 11,700 years may represent not just geological coincidence, but a period of cosmic quiet during which our planet has been largely isolated from the kind of external influences that our recent visitor brought to our solar system. This stable period coincides with the development of human agriculture and civilization, suggesting that our species' rapid cultural and technological development may have occurred during an unusually peaceful interval in cosmic history. Cosmic ray climate theory, still controversial within mainstream climate science, suggests that variations in galactic cosmic ray intensity can affect cloud formation and atmospheric chemistry in ways that influence global climate patterns. Interstellar visitors like our cosmic wanderer could affect cosmic ray flux through electromagnetic interactions, or by altering the heliosphere boundary conditions that regulate cosmic ray penetration into the inner solar system. The weak anthropic principle, applied to planetary habitability, suggests that Earth's ability to support complex life depends on an extraordinary number of cosmic and terrestrial factors maintaining precise relationships across geological timescales. The correlations we've observed between our visitor's passage and terrestrial anomalies hint at how sensitive these relationships might be to external influences that operate beyond the familiar parameters of solar system dynamics. Planetary protection mechanisms, evolved over billions of years to shield Earth from cosmic hazards, may have been tested by our visitor's passage in ways that revealed both strengths and vulnerabilities in the systems that maintain habitability. The magnetic field fluctuations, atmospheric disturbances, and seismic anomalies we observed represent responses that demonstrate Earth's ability to adapt to cosmic influences, while also revealing the limits of planetary resilience. The Goldilocks zone concept, describing the orbital region around stars where liquid water can exist on planetary surfaces, may represent only one factor in the complex array of conditions necessary for sustaining life. Our observation suggests that ongoing cosmic influences, including periodic visits from interstellar objects, may play essential roles in maintaining planetary systems within the narrow parameter ranges required for biological complexity. Electromagnetic pollution from human technology has created artificial sensitivity to cosmic electromagnetic influences that may not have existed during earlier periods of Earth history. Our satellite networks, power grids, and communication systems represent vulnerable technological infrastructure that could be affected by cosmic influences that pose no threat to pre-industrial human societies. The precautionary principle suggests that humanity should prepare for the possibility of increased cosmic visitor frequency as our solar system moves through different regions of galactic space, or as interstellar travel becomes more common among technological civilizations. The correlations we have observed between our recent visitor and terrestrial anomalies provide a preview of how such encounters might affect planetary systems and human infrastructure. Future preparation requires developing planetary monitoring systems capable of detecting cosmic influences before they manifest as terrestrial anomalies, creating early warning capabilities that could help mitigate the effects of gravitational, electromagnetic, or other exotic influences on Earth's interconnected systems. Such systems would represent a form of planetary immune system designed to protect terrestrial habitability from cosmic disturbances. The consciousness factor in planetary stewardship takes on new significance when viewed through the lens of cosmic terrestrial connections. Human awareness of our planet's sensitivity to cosmic influences creates both responsibility and opportunity for developing technological and social systems that can adapt to and possibly benefit from ongoing cosmic interactions. Ethical implications of cosmic terrestrial connections extend beyond environmental stewardship to questions about humanity's role in galactic ecology and our responsibilities as a potentially spacefaring species. If Earth's systems are sensitive to cosmic influences, then our own future activities in space may affect other planetary systems in ways that require careful consideration and ethical framework development. The partnership model for understanding cosmic terrestrial relationships suggests moving beyond the traditional view of Earth as passively subject to cosmic forces toward recognition of active participation in galactic-scale systems. This perspective implies that planetary systems may play essential roles in cosmic ecology, contributing to galactic stability and evolution through mechanisms we're only beginning to understand. Technological evolution requirements for a cosmic-aware civilization include developing capabilities for monitoring, predicting, and possibly moderating cosmic influences on planetary systems. Such technologies would represent natural extensions of existing Earth system science, but operating on scales and according to principles that integrate planetary and cosmic perspectives. The long view of species survival suggests that understanding and adapting to cosmic influences may be essential for any civilization's long-term persistence. The correlations we've observed between our visitor's passage and terrestrial anomalies provide crucial insights into the kinds of cosmic terrestrial relationships that may characterize normal galactic ecology rather than exceptional events. Indigenous wisdom traditions that preserved knowledge of sky-Earth connections across thousands of years offer valuable perspectives on living in harmony with cosmic influences, rather than treating them as external threats to planetary stability. These traditional knowledge systems recognized cosmic terrestrial relationships as fundamental aspects of planetary existence, rather than anomalous disturbances requiring technological solutions. As we contemplate the cascade of anomalies that marked our cosmic visitors' passage through our solar system, we must recognize that we have witnessed not disruption, but revelation, the unveiling of relationships that have always existed between planetary and cosmic systems, but remained hidden beneath the familiar rhythms of terrestrial existence. Every aurora that painted impossible colors across temperate skies, every earthquake that awakened sleeping continental foundations, every magnetic field fluctuation that revealed planetary sensitivity to cosmic influence, spoke the same profound truth. Earth dances not in isolation, but as part of a galactic symphony where every note matters, every rhythm connects, and every visitor adds its voice to the cosmic music that shapes planetary destiny. Our wandering mountain may have come not as disruptor, but as teacher, demonstrating through its passage that the boundaries between terrestrial and cosmic, between planetary and galactic, between local and universal, are far more permeable than our Earth-centered science had ever acknowledged. In learning to recognize these connections, we begin to understand our world not as a fragile island of life, floating through hostile emptiness, but as an active participant in cosmic systems that operate according to principles as beautiful as they are profound. The fragile balance that sustains life on Earth includes not just the familiar cycles of water and carbon, atmosphere and ocean, but ongoing dialogue with cosmic influences that help maintain the dynamic stability necessary for biological complexity. Our planet listens, always listens, to voices that call from beyond the sky, responding with tremors and lights, and magnetic whispers that speak of sensitivity refined across billions of years of cosmic evolution. In recognizing this cosmic sensitivity, we discover that Earth's greatest strength lies not in isolation, but in connection, not in resistance to cosmic influence, but in the exquisite responsiveness that allows our world to dance in harmony with galactic rhythms, while maintaining the stable conditions that nurture the extraordinary experiment in consciousness that we call life. The universe speaks, and Earth answers, and in that eternal conversation we find our place not as observers, but as participants in the cosmic symphony that connects every star to every stone, every visitor to every home, every journey to every destination in the vast web of existence that embraces all worlds, all lives, all possibilities that emerge when cosmic and terrestrial forces join their voices in the endless song of universal becoming.